Okay, so let's walk through an example, and we're going to take this example out of the book. It's question number 24 on page 299. So it says, in 1974, Loftus and Palmer conducted a classic study demonstrating how the language used to ask a question can influence eyewitness testimony. Loftus is one of my favorite researchers in the history of research. Her work is so fascinating. Anyway, in the study, college students watched a film of an automobile accident and were then asked questions about what they saw. One group was asked about how fast were the cars going when they smashed into each other. Another group was asked the same question, except the verb was changed to hit instead of smashed into. The smashed into group reported significantly higher estimates of speed than the hit group. So in other words, one group was asked, how fast do you think those cars were going when they hit each other? Another group was asked, how fast do you think those cars were going when they smashed into each other? Smash sounds faster than hit, right? That's the idea, that the language is influencing how they remember things. Anyway, suppose a researcher repeats the study with a sample of today's college students and obtains the following results. And we can see estimated speed, smashed into group, and their stats, and the hit group. Well, first thing to note is in a problem like this, it hasn't been specifically delineated which is group 1 and which is group 2. And that can really matter, particularly when we're subtracting things. So if it's not specifically said, just like we read left to right, the first group you encounter is group 1, the second group listed is group 2. That'll be universally true for us. So the smashed into group is the first group on the table on the left. So they're our sample 1, and the hit group is our sample 2. So we just have to make sure we keep that straight. And we're going to run our regular 4 steps. On part A here, it says use an independent measures t-test with a 0.05 to determine if there's a significant difference. So again, if we're just asking are things different, that's a two-tailed. So step 1. Oops. Again, there's only one way to write any of these for this chapter. The alternate hypothesis is treated population mean 1 compared to treated population 2 will result, I'm sorry. Oh no, I was right the first time. Will not result in any differences. I'm trying to speak it differently than I normally do and I screwed myself up. So treated population mean 1 minus treated population mean 2 will not equal 0. These two numbers will not be the same. They'll be significantly different. The null hypothesis is treated population mean 1 minus treated population mean 2 will equal 0. That these two numbers will be the same. The language won't make a difference. Smash folks won't give an answer that's any different than the hit group. So that's step 1. Again, there's nothing else to write here. There's no numbers to take out of the story problem. We just take it as it is there. Step 2. Getting the value of our critical t. Well, we know it's a two-tailed test. The alpha level is 0.05. And when we look at the problem, we see that there were 15 people in the first group. So the degrees of freedom for the first group was 14. And we have to then look at the second sample. The degrees of freedom for the second sample is also 14. There were 15 people in each group. So our total degrees of freedom for this study is 28 points. First group plus the second group. So you go to the same t-table we used in the last chapter, go down to the heading for two tails, go over to 0.05, and go looking for your degrees of freedom. Remember, if your value is not there, look for what's closest. If there's no closest, go to the one that gives you the larger t. When you do that, you should find that your critical t value is positive or negative 2.048. So, just like always, we set up our critical regions. And we either get above a 2.048 or below a negative 2.48. If we land in the shaded areas, we reject. If we land in the body, we fail to reject. So that's step 2. Step 3, doing the math. So the first thing we have to compute is our pooled variance. We need to get a value for variance here. And again, first calculation, one long formula. Again, for some of these homework problems, just like in the last chapter, you're going to have to figure out, well, what are they giving me? How do I use those parts to get what I need? They may not give you sums of squares. They may give you something else that you have to use to find sums of squares. So again, there's a little bit of critical thinking that goes into some of these problems. But in this case, we're told that the sums of squares for the first sample is 510. And we're told the sums of squares for the second sample is 414. Degrees of freedom for the first group is 14. Degrees of freedom for the second group is 14. So when we calculate that, we find our value for pooled variance, you should come out to a value of 33 points. So now that we have our pooled variance, we can use that to calculate our estimated standard error. So again, we're going to have pooled variance divided by the first sample size, then calculate the pooled variance divided by the second sample size, add those two values together, then get your square root. Well, we know that the pooled variance is 33, the first sample size is 15, and we end up with the exact same fraction on the other side. The numerators will always be the same. It's always pooled variance on the top of both. And because both groups are the same size, we've got the same denominators. So again, you want to calculate your 33 divided by 15, and then add it to another 33 divided by 15. And when you do that and then square root, the number you're going to get should be 2.0976, and on it goes. So we know we're going to round that to 2 places. So we're going to end up with a value of 2.10 here. And then our third and final calculation is for the t statistic itself. So, again, which one is sample 1? Sample 1 is the smashed into group. That's the one on the left, the first one listed. And it tells us that their mean was 40.80. And the second group has a sample mean, it says, of 34.90. Now, here's the thing. It's not really going to make a difference to the final answer in this problem, but it will make a difference in the final answers of other problems. Let's move up a step. Back up here, or up a calculation for our estimated standard error. We wrote down the answer as 2.10. We have to write rounded answers. It was an infinite non-repeating decimal. We can't write the real answer forever. We'd go the rest of our lives and still not be done, right? As we've talked about before. We've got to round somewhere, so we're rounding at 2.10. But that's not really the answer. We're accepting that as the answer written down because we have to accept our rounded answers. But what are we going to divide by down here? If I put in 2.10, I'm putting a rounded number down here. That rounded number, remember, every time we round, there's error associated with that. So what we're going to do is by using a rounded value down here, by using 2.10, we're actually going to throw off the t statistic a little bit. So listen very carefully. We must write down, we must report rounded values, but we want to calculate using the full unrounded values. So in other words, when we subtract this out, we don't want to divide it by 2.10. We want to divide it by 2.097600, or on and on it goes, whatever the number was. So there's two ways of doing that. The easiest way is to have that real answer, that 2.0976 ... in your calculator's memory function. If you don't know how to use your calculator's memory function, I'm sure there's 1,000 YouTube tutorials. If we were in class, I could probably show you for most of your calculators. But often it's a matter of finding a button called STOW for storage. And then for many of you, your calculators are going to have multiple memory banks. So some of you in your displays, you might see the letters A, B, C, D, E. You've got to pick one of those as a file to put it in. And a calculator like mine, you just pick a number. So I would say store it in memory bank 1. Or the other thing you can do is on your scratch paper, write down the full value out to say, 5, 6 places would be sufficient. We don't need to go much further than that because we're always rounding back down to 2 anyway. And so what I'm going to write down here is 2.10 in the denominator, but what we're really dividing by, the actual dividing we're doing back here, is the 2.0976, on and on we go. So again, we're going to report rounded values, but we're going to calculate with the full unrounded values. In a problem like this, where there's only one rounded value going in, as I said before, it's not really going to make a difference to the answer for us. When we calculate it, whether you use 2.10 or you use the 2.976 ... number, the rounded or unrounded values, what we're going to end up with is either 2.8095 or 2.8127. Either way, we're going to round to 2.81. So we would get the same answer no matter which way we did it right here in this problem. But this is an important thing to learn to do now. In 2 chapters from now, starting in chapter 12, we're going to have 9 calculations to make. So now imagine if we had to round this value, and then we put a rounded value into this calculation, and then we round this answer, and then we put that rounded value into this answer. Every time we're going down the chain with a rounded number, we're putting more and more and more and more error into the system, so that by the time we get to the last calculation, our answer could be quite a bit off of the actual answer. Now note that sometimes in the answers in the back of the book, your authors do it the way we're talking about it, and sometimes they don't. I wish they were a little more consistent in that way, but nothing I can do about that. So these are our classroom rules. We write down rounded values, but we calculate with the unrounded values. Always, always, always. So our t statistic is 2.81. Our critical t was 2.048. So 2.81 is going to land there. So that is the comparison we need to make, of course, for step 4. So in step 4, we're simply going to report our decision, which we saw we're in the critical region there. So we are going to reject the null hypothesis. And if we needed to write this in APA format, we would say that we had a t of 28 that equaled, what do we have, 2.81. P less than 0.05. So those were our 4 steps for the 2-tailed version of this. In the next video segment, we're going to go back like we always do and look at this problem as though it was 1-tailed.